Like all control products, sometimes we need to diagnose system issues in the field. Now, to do that, there are some basic principles you've got to remember. Firstly, has the controller been used in the correct application? Has it been used in clean water? Has it been used in dirty water? Is there any other aspect that can impact the controller? These are core questions that we would ask you, and you would ask your end user when it comes time to diagnosing a system problem in the field. When you start looking at the controller, first thing you need to know is it's not rocket science. It's very easy to access. 4 screws at the front, open it up, and you can get complete access to the controller's control board, what we call the PCB. Now, typical control boards, there is usually 1 or 2 aspects which can cause problems with any control device. In the case of the iPress Pro, we typically find that the reed switch on the top is the area which will stop the controller from not turning off. Now, you can diagnose this by using a simple everyday multimeter and testing for conductivity around the reed switch itself. Quite simple to do. Turn your multimeter on, put the probes into either side of the reed switch, which you can see here. Then you can tell that immediately there should be no conductivity between those 2 reed switches, between those 2 points. But as the system uses a magnet-based flow sensor, when a magnet that is in good condition passes by, the system should be able to activate. That will tell you that as the moment that this magnet drops down when there's no flow, the controller will turn off. So that reed switch in this case is in good operational condition. Now, what happens when a customer has pumped the wrong type of water? Water with high pH or low pH, water that's got high salinity, alkaline, something that's going to react with the metals in the magnet. In this case, here is an example of one. We removed this out of a controller recently that was pumping bore water. Now, what happens when a degraded magnet is used? It's quite simple. No signal. No signal means that this magnet will not turn off the controller, which means the controller, when the pump is operating, will detect a flow requirement all the time if the pressure is dropping, if there's a leak, and continue to cycle, leading to potential pump problems in the future. This is the first of all the points that we inspect, why a controller doesn't turn on. What happens when a controller doesn't turn on or off can also be governed by the protection built into the controller. So if you're looking to say, well, the pump's not turning on all the time, maybe there's been a P-, error, maybe there's been an A-, error for short cycle protection, or maybe there's a pressure error in the system. The controller will display that on the display, and you'll be able to tell by looking at it in the system. Now, the easiest way to check if there has been an error and it has been locked out is quite simple. Turn the power off to the controller, let it discharge for a period of 5 minutes, turn it back on and see if the system primes again.